Okay? So what does simulation mean to you? Anybody want to venture a guess? It's okay.
It's like fabricating a real life experience and things.
Sure, exactly. Perfect. It's you're doing an experiment. Hello, guys. You're doing an experiment that's replicating or standing in place of an actual experience. So, for example, guys, could I measure the heights of every year 7 student in New Zealand?
No. I mean,
It would take forever, right? And probably by the time I got around to it, the first one would have grown. So, it's not always practical to perform an experiment.
And then you'll have their heights and they won't grow.
No. All right, so it's not always practical, guys. It's not always practical to perform an experiment on a particular group, and it's not always possible to be able to perform an experiment to represent every situation. So we use instead what are called simulations, where we're going to do some other activity, but use it to get a theoretical probability or an experimental probability for, guys, for another activity. Okay? All right. So, we're going to look at a couple of different simulations today. Again, why do we use simulations? It's easier to use a simulation than it is the actual experiment in most cases, okay? So what we're going to do today, this experiment we're going to do, and we're going to design, and you're going to help me design it, decide how to do it, okay? So focus, all right, is we're going to see what the probability is that a couple is going to have 3 babies, and one of the babies is going to be a girl.
At least one or only one?
Only one. Okay? So they're going to have 3 children, and one of them is going to be a girl. So we could go through and ask everybody on the planet who has 3 children and count the ones that have exactly 1 girl, right?
That's Caitlin. That's me. She has
Okay.
2 brothers and she's
There you go. So we're looking at your family, the probability for your family. All right. But is it practical, guys? Is it practical to wander around? Okay, here we go. So what we're going to do is, would it be practical to go around and count every family in the world that has 3 children and find out how many of them have exactly 1 girl? No. Would it even be practical to do that in New Zealand?
No.
Even Wellington?
Yeah.
Yeah, it's very difficult when you start getting to get large numbers. So instead, we can perform a simulation where we let something stand in for our desired measurement, the thing we're trying to measure. Okay? So what we're going to do today is we're going to look at and build, and you're all going to help me build this. We're going to build an experiment or a simulation that would tell us, so we could determine the probability of a family having 3 children where exactly one of them is a girl. Okay? So let's talk first. Let's just see if we can make a list of some information we think we need to have. Yes, you may. What's going on?
Can the woman get pregnant?
Yeah.
That should be a big one.
All right. Well, we're going to assume that's okay. That they can have the 3 children. Okay? So what kind of things do you think we need to take into consideration? So first of all, what kind of... So we're talking about just having a girl. Is a girl the only thing that can happen? No, you can have what? Yeah, so we could have either boy or we can have a girl. Do you agree? Okay. Right? So they can. We're going to discount twins. We're just going to say they're going to have 1 baby at a time.
Don't exist.
We're just not putting them in our measurements. They exist, you guys. All right. So when you're having a baby, you can either have a boy or you can have a what? Girl. Right? And we looked at this.
What if the child is intersex?
Okay, hold on. So we look. Oh. Come on, I'm old. Leave me alone. Yes.
What if we're like one of those 11 people who happen to be both genders?
There you go. So let's just, for the sake of our argument, say that these people had either a boy or a girl. Okay. All right. I swear, should I have picked hamster, cat, and dog? Okay, so here we go. Back. Okay, here we go. Simulations. We're going to run a simulation where a family has to choose a pet, and they're only allowed, they're going to pick 3 pets, but they're only allowed to pick between a dog or a cat. Doesn't matter. We've already been down that road. We're not going again. All right. So, a dog or a cat. No other animals possible, right? But they're going to have a total of 3 pets. Okay? We want to... Writing it down would be a good thing. So remember, anything I write should be important enough for you to write. Okay? These are notes. Okay? And so I want to know the probability of only 1 cat. Can anybody tell me another way of writing this probability? Probability of what? Cat.
We'll see.
Okay? But remember...
1 cat. So, no, C1. Let the class. 2D. 2D. C2D. C2D.
Why 2D?
Because 2 don't know.
Because if you get 1, you can only have 1 cat means you're going to have 2 dogs, right? Okay? So, different ways of writing it, but what I want you to get used to, so can you think of any others? It's probably the easiest ones.
Like any animals? Like,
Yeah.
Like hamsters or...
Well, no, I'm just saying here, for this particular situation. 3 pets, 1 cat, 1 dog.
1/3 cat. What if? No,
Okay.
what if they got...
How about if we did probability of cat, dog, dog? We could do something like that. But one of the things I want you to remember, because it's been a while since we did probability together, is that, guys, your labeling must be very specific and be careful. When we're doing the assessment and you do the probability of something, if you don't put this notations down, some kind of notation that is specific, you will get it wrong.
You'll get a fail, guys.
All right? Okay? So be careful. All right, so we're looking for the probability of getting just 1 cat out of the 3 pets. And that means you're going to get 1 cat and 2 dogs. Okay? But I can't go around counting all the cats and dogs in Wellington or New Zealand, right?
I can help. I have a cat and a dog.
So, okay? So what I need to do is we're going to design an experiment. And so, what did I just bring into the class? Dice.
Die.
So I want you to think about how could we use a die, singular, 1
You
die,
said it to me. It was Claudia.
a die. Oh, I thought, okay.
I also said die.
Okay, very good job. Good job. Everybody gets credit for it because, I don't have any favorites. Come on. So, die. We're going to use a die to determine an experiment about it, right?
Yes.
Okay. But I get a problem. How many sides does a die have on it?
6.
But I only get cat or what?
Dog.
Even
So what can I do, you think?
Even odd numbers.
There you go. Okay, guess. What was you going to say?
You can take the dice and make half of them for dogs and half of them for cats.
Okay.
Yes, but
Well, I don't have any paint, but yes. Yep, but I don't have a coin. All I have is a die. Yes, but that's excellent because that's where I was going next. So, if you have 6 numbers on a die, I could say that the odd ones stand for the cat, the even ones stand for the dog, or vice versa. Does it matter? No, because we know that every side of a die has an equal probability of being rolled, right? Now, what if could I say that the cat is a 3 and the dog is a 4?
Yeah.
Would that work?
Probably no.
I'm going to go with not. Good. And did anybody say why? Think about why.
Because.
The other 4 options.
Well, actually, why not?
The other options, right? You have all those other numbers that you're not using. And those numbers, you can't be excluded from a die. Now, we could do it with another object, though. Can anybody think of what object has exactly 2 sides? It's easier. There you go. So you could do heads and tails. Now, we're going to use the die because that's what I brought. That's what we're going to do. And I have one for everybody. And I'm not passing out money to you guys. So, sorry. But you could do it with lots of others. But I'm using the die specifically to demonstrate that you can use, even though they're just 2 objects, you can use an object that has 6 sides. But you're just going to have to think about it a little differently, right? Evens versus odds. Okay? Yeah. Now, what if you had a die that only had 5 sides? Because those exist.
They do.
Could you do evens and odds then?
No,
because there are more what?
It's not even.
It wouldn't be 50.
There are more odd numbers than even numbers, right? It's not.
1
But
odd,
you
2
can just like
even.
say that one of the numbers won't count as 1.
Okay. So yeah, you could, but that would give you some trouble, right? Because then you might have to end up rolling it more and more and more and more, and we don't want to have to do that. Okay. All right. So do you see that you can use other objects to stand in for some others? So who would like to make sure that every table has 1 die? Somebody.
I want to, please.
There you are. Would you mind then, please? Okay.
And that's the blue one.
Again. All right. Now what we have to do is we have to think about how can we arrange our data. How can we arrange our data to be able to work with this? So what are we going to have? How many pets are they going to have?
2, 3.
3, right? So they can have, but we only want them to have what? How many cats?
1.
So they can have a dog, they can have another dog, and they can have a what? A cat, right? So 3 different things. And what we want to do is we're simply going to do this experiment several times and see what combinations we get. Now, we do have to decide, though.
Do we have to do this 2?
You're going to draw it because you're going to make it.
How many things do we have to do?
Oh, we're going to do about 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at me. I'm so good. I got so lucky. So we're going to do 10 trials. Yes.
Can I open my laptop, please?
Okay. What for?
Is that okay? Can I open my laptop for no reason at all?
No.
That's.
Wait, will I
That's-
do this? Will I
Okay.
do this?
Yes. So you're going to draw a chart that looks like this.
Would it be examples?
Yeah, you can put this in your examples.
Okay.
Because this is an example of a simulation. Now, remember, we're rolling die.
I didn't put it in my examples, I put it in my notes.
It's fine. You're good. You're good. All right. So we need to decide, though. Remember, we have even numbers and we have odd numbers. If we're going to do this simulation, we have to determine, are we going to use an even number or to represent a cat or an even number to represent a dog? Which one do you want?
Cats are odd. Can they please be odd numbers?
Cats are odd. Fine with me. Which makes dogs even. That's no big deal.
Are you a cat person or a dog person?
All right. Okay. So what we're going to do is, think about it. Each one of these, so we're going to do this 10 times. And do you remember from our vocabulary that each time you do it is called a trial, right? So we're going to do 10 trials. Each thing you get is an event. Do you remember that? Okay, don't forget your vocabulary. So what you're going to do is you're going to roll your die, and you can take turns in your groups. Roll the die, and in the interest of sanity, maybe we only want to do 5 trials.
Excuse me, I drew 10.
All right, keep doing it. Keep going 10. That's fine. All right, so what I want you to do is, right? So let's do the first one together. So somebody, here you guys, somebody at this table, roll your die. What do you get?
5.
So 5.
Kitty.
Okay? So they got a 5, which is a cat, right?
Yeah.
Okay? Yeah, we're using this as the first one. Okay? Now roll again.
Three.
3. So right away,
We have 2 kitties.
that's 2 cats. So we know that that one's not going to work. We're not going to happen, right? Okay? So we have one that's not going to work. We don't really care what it is because we're calling success only 1 cat, right? Oops, sorry.
So what do we do?
So-
Like a line?
So you can just mark that one off or put an X by it or something like that. That one didn't work, did it? Remember the probability tree where we talked about how a branch worked or not? We don't care about the ones that don't work, do we? What are we going to count?
The ones that work.
The ones that worked. Okay? So now just roll your die and get me 10 trials, and they're all going to be different. So we're going to have different probabilities as we go. So go. Yes. Just do 10. They want to do 10, so it won't take very long. So we see here are all the probabilities that you got, all the different probabilities that you got by using this simulation. Yeah? So do you see a pattern happening? Are they very close or they're pretty similar?
They always think at the bottom. Oh.
Well, yeah, Caitlin.
You didn't get any more than half the time, did you? Most of the time it was slightly less than. We actually got 1, 2, 3, 4, 5. We got every combination up to 5, right? Did we have any 0?
Cat got 4 out of 5.
Oh, 4 out of 5? Okay. So you got a huge number out of it, okay? All right. So there was a big range in our simulation. Okay. There was a big range in our simulation. Do you agree? Okay. Now,
We don't like big brains.
okay. So, but when you think about it, though, how many times did we do it? 10. Do you think 10 is very good for a simulation?
Do like 100.
Yeah.
No.
We would generally have to do way more. So remember, guys, we have theoretical probability, which is that perfect mathematical probability. And then we have experimental probability, right? And we never really expect experimental probability to match theoretical probability, okay? Right? But it could if you did what? Like millions and millions and millions. Like you could set a computer running to do this and let it do it millions or hundreds of millions of times, and it would probably come close to the theoretical probability. Another way you could do this is by doing it over and over or having different groups do it over and over and finding an average. Right? An average. Okay? And so that's what we're going to look at. But before I went through the definitions and all the Education Perfect one, I wanted you to see this one. And now we're going to look at one that they've completed that has given you all of the pieces. All right. So data collection you can look at it. One of the types of things you can use is called a simulation. It involves modeling a real life situation using other methods such as tossing a coin, rolling a die, or using what's called a random number generator, which we will use next time. So make sure that you bring your calculators next time. We'll use a random number generator. Okay? All right, good. Just want to make sure. All right, some events may be too difficult or expensive to study, but you can use a simulation. So we discussed that, right? So we can use simulations using a random number generator on a computer or a calculator, and you can use that to be able to give a number that comes within a specific range. For example, we could use either a 1 or a 2 to represent cat or a what? Dog, right? So our random number generator would only generate 1s or what? twos, right? Okay. Now, what if I had, guys, do you remember me? All right. What if I had 7 different objects? I would use a random number generator to generate numbers between what?
1, 7.
1 and 7. There you go. Good.
1, 14.
Okay. All right. Here we go. So a farmer knows that approximately 1 in 6 ewes on our farm will produce twin lambs. How could you use a simulation that should sound very familiar to you?
What's it, EVs?
Ewe.
Ewes.
Ewe is a female sheep. A mama sheep. All right. So if she had between 1 and 6, what is a really easy thing, guys? What is a really easy thing to use? A die, right? Because it has exactly 6 numbers on it. You wouldn't have to think even or odd. Good. Okay. So you could use a die to simulate the total number. Okay. So let's look at an example. Bethany is wanting to model the number of traffic accidents at a dangerous intersection. Statistics show that 1 in 10 vehicles are likely to have an accident at the intersection. How can she design a simulation to model the future number of accidents? Okay, so think about a way you could do that. And of course, we'll go ahead and just look at what they say. 10-sided die. Look at you. Or a random number generator, because how many of you have a 10-sided die? Okay. There you go. And you need to do it over and over and over again to be able to make a good prediction. Okay? All right.